Around 66 million years ago, a catastrophic event changed the course of life on Earth. An asteroid, roughly 10 to 15 kilometers wide, collided with our planet near what is now the Yucatan Peninsula, creating a crater over 150 kilometers in diameter. The impact triggered massive wildfires, shockwaves, tsunamis, and a dust cloud that enveloped the globe, plunging it into darkness. The result was a prolonged period of cooling, known as the impact winter. The devastation caused by this event led to the mass extinction of nearly 75% of all life forms, including the non-avian dinosaurs that had dominated the Earth for over 160 million years. With these massive reptiles gone, entire ecological niches were left vacant. The world's landscapes began to change, and new opportunities emerged for the creatures that had survived. In this post-dinosaur era, mammals, which had been relatively small and nocturnal under the rule of the dinosaurs, began to evolve in new directions. As the Earth's ecosystem stabilized, mammals diversified into various forms, some of which grew to astonishing sizes. Without the competition from dinosaurs, these early mammals could expand into the ecological spaces previously occupied by giant herbivores and predators, paving the way for the rise of what would become the largest land mammals to ever walk the planet. One of the most remarkable examples of this phenomenon was the emergence of Paraceratherium, the largest land mammal known until recently. Paraceratherium lived approximately 34 million years ago, during the Oligocene epoch, and was a member of a group called rhinoceroses. This colossal creature stood at least 4.8 meters, 15.7 feet, tall at the shoulders and weighed an estimated 15 to 20 tons. It roamed the forests and plains of Asia, where it fed on soft vegetation from tall trees, much like modern-day giraffes. For a long time, Paraceratherium held the title of the largest land mammal, unmatched in size and weight. However, another massive creature from the mammalian lineage was lurking in the shadows of history, waiting to be unearthed and recognized. This was Palaeoloxodon namadicus, a prehistoric elephant discovered in India in the 1800s. Early fossils of Palaeoloxodon suggested that this elephant was not just large, but possibly even larger than Paraceratherium. While the size estimates were initially tentative due to the fragmented remains, paleontologists quickly became intrigued by the possibility of an even larger land mammal. The genus Palaeoloxodon traces its origins to Africa, approximately 4 million years ago. One of its earliest known members, Palaeoloxodon recchi, roamed the African continent and displayed traits that would be further developed by its descendants. Over time, members of this genus began to migrate out of Africa and spread across Asia and Europe. By around 600,000 to 800,000 years ago, different species of Palaeoloxodon had reached Europe, the Middle East, and the Indian subcontinent. This migration led to the development of various species adapted to different environments. One of the notable species that emerged in Europe was Palaeoloxodon antiquus. This species, commonly known as the straight-tusked elephant, grew to impressive proportions, weighing over 15 tons. It became widely distributed across Europe, reaching as far as the British Isles during warmer interglacial periods. Interestingly, some populations of Palaeoloxodon antiquus that became isolated on islands such as Sicily and Malta evolved into smaller dwarf forms due to the limited resources available in their insular environments. This phenomenon of island dwarfism illustrates the adaptability and diversity of the Palaeoloxodon genus. The largest species within this genus, however, was Palaeoloxodon namadicus, which inhabited the Indian subcontinent. This colossal elephant lived approximately 700,000 years ago and was estimated to have reached heights of over 5.2 meters, 17.1 feet, at the shoulders. Its weight was projected to be around 22 tons based on femur measurements, making it a strong contender for the title of the largest land mammal ever. Despite these impressive figures, the initial size estimates were not universally accepted due to the incomplete nature of the fossil record at the time. The genus Palaeoloxodon's evolutionary journey is a testament to the adaptability and resilience of these prehistoric elephants. As their ancestors spread out of Africa, the Paleoloxodon species diversified in response to varying climates and landscapes, leading to the emergence of giants like Paleoloxodon antiquus and Paleoloxodon nammedicus. While the former thrived in the temperate climates of Europe, the latter grew to immense proportions in the warmer regions of the Indian subcontinent. The remarkable evolutionary path of this genus highlights the ability of large mammals to migrate, adapt, and evolve in response to changing environmental conditions. The discovery of Paleoloxodon nammedicus in India was a significant event in the field of paleontology, as it suggested the existence of a land mammal that could rival or even surpass the size of Paraceratherium. The early fossil findings were limited, comprising mainly skull fragments and parts of the limbs, making it difficult to accurately determine the full size of this prehistoric elephant. Nevertheless, paleontologists were able to make educated estimates based on comparisons with other species within the Paleoloxodon genus and the available skeletal remains. Over the years, additional fossil discoveries helped to paint a clearer picture of Paleoloxodon nammedicus. By examining the femur and other large bones, researchers were able to estimate that this species could have weighed between 18 to 22 tons, with some studies even suggesting higher figures. These estimates placed Paleoloxodon nammedicus firmly in contention for the title of the largest land mammal, surpassing even the previously uncontested Paraceratherium. The spread and diversification of the Paleoloxodon genus offer fascinating insights into the migration patterns and adaptability of prehistoric elephants. From their origins in Africa to their expansion into Europe and Asia, the genus evolved to produce both massive and diminutive forms, depending on the environmental pressures they encountered. The existence of Paleoloxodon nammedicus in the Indian subcontinent highlights how these elephants were able to thrive and grow to immense sizes in a variety of climates and habitats. In recent years, the discovery of more complete specimens of Paleoloxodon nammedicus has shed new light on its true size and reinforced its status as the largest land mammal ever. A 2023 study reported the discovery of a relatively complete skeleton of this prehistoric giant, providing crucial new information about its anatomy and size. The findings confirmed that Paleoloxodon nammedicus was indeed a true colossus, weighing an estimated 18 to 19 tons. These revelations have solidified its position as the largest land mammal, finally dethroning Paraceratherium from its long-held title. The story of Paleoloxodon nammedicus and its relatives is a powerful reminder of the incredible diversity and adaptability of life on Earth. From their humble beginnings in Africa, these prehistoric elephants embarked on an evolutionary journey that took them to different corners of the world, leading to the rise of the largest land mammal in history. The ongoing discoveries and research into this fascinating genus continue to expand our understanding of prehistoric ecosystems and the remarkable creatures that once roamed our planet. Despite the groundbreaking discovery of Paleoloxodon nammedicus, its estimated size was met with skepticism within the scientific community. One of the primary reasons for this doubt was the fragmented nature of the fossil remains found in earlier excavations. Initial size estimates were based on large but incomplete bones, such as partial femurs, vertebrae, and skull fragments. While these pieces provided some insights, paleontologists understood the limitations of reconstructing an entire skeleton from a handful of bones. Consequently, debates arose over whether the calculations might be inflated or based on incorrect scaling models. Fossil records for large prehistoric mammals are often fragmented, leading to variability in size estimates. This was particularly the case for Paleoloxodon nammedicus. Previous comparisons to other species within the Paleoloxodon genus, and even to modern elephants, yielded a range of possible sizes. Critics of the earlier estimates argued that basing the weight and height of an entire creature on just a few bone measurements leaves room for significant error. Moreover, given that the genus Paleoloxodon included a variety of species, some with quite different body proportions, generalizing from one species to another was risky. However, the scientific community got a much-needed breakthrough in 2023. A new fossil discovery, dubbed CF Paleoloxodon namadicus, was more complete than previous finds. This specimen provided additional skeletal pieces, such as a nearly complete femur and pelvic bones, allowing researchers to refine their understanding of the elephant's proportions. Detailed analysis of these bones led paleontologists to revise their estimates, confirming that Paleoloxodon namadicus could indeed reach a weight of 18 to 19 tons. These new findings placed Paleoloxodon namadicus firmly in the category of the largest land mammals ever to walk the Earth. Researchers were now confident in asserting that this prehistoric elephant had surpassed Paraceratherium in terms of weight and height. The updated estimates suggest that it stood at least 5.2 meters, 17.1 feet, at the shoulders, making it not only heavier, but also taller than the famous Paraceratherium. As researchers delved deeper into the skeletal structure of Paleoloxodon namadicus, they uncovered various unique physical traits. One of the most distinctive features was its robust and heavy skull, characterized by a prominent crest on the top. This crest, known as the parietal crest, served as an attachment point for large muscles that connected to the jaw. The heavy musculature was essential for an elephant of such massive proportions, as it would have required significant force to chew through the tough grasses and foliage that made up its diet. The tusks of Paleoloxodon namadicus were another standout feature. While modern elephants have long, slightly curved tusks, Paleoloxodon namadicus took this to the extreme. Its tusks were not only longer, but also heavier, suggesting a dual purpose of display and defense. Tusks are not merely for combat. They serve social roles as well, signaling an individual's dominance or health. The impressive size and curvature of these tusks likely made Paleoloxodon namadicus an imposing figure in the prehistoric landscape. Despite its sheer size and intimidating appearance, Paleoloxodon namadicus was primarily a grazer. It roamed the grassy plains of what is now the Indian subcontinent, consuming vast quantities of low-lying vegetation. Based on modern analogues, researchers estimate that an adult Paleoloxodon namadicus would have needed to consume upwards of 150,000 calories a day to sustain its massive body. This amount of food intake translated into several hundred kilograms of grass and leaves daily. Given its size, Paleoloxodon namadicus would have been slow-moving but incredibly efficient at stripping entire patches of grasslands bare. As with all large creatures, Paleoloxodon namadicus faced potential threats, although not from other animals. Its size and thick skin rendered it virtually invulnerable to most contemporary predators. Unlike the smaller species of Paleoloxodon or modern elephants, which sometimes fall prey to large carnivores, Paleoloxodon namadicus would have had little to fear from the big cats and scavengers of its time. However, the only true threat to this giant might have come from an unexpected source: humans. Evidence indicates that Paleoloxodon namadicus coexisted with early humans during a critical period in prehistory. Although direct evidence of humans hunting Paleoloxodon namadicus remains elusive, findings at other Paleoloxodon formation sites suggest that humans were indeed interacting with, and sometimes hunting, these massive animals. In particular, remains of Paleoloxodon antiquus have been found alongside primitive hunting tools, indicating that early humans targeted these giant elephants for food. Hunting a creature as large as Paleoloxodon namadicus would have been a daunting task, requiring sophisticated hunting strategies and coordination among groups of early humans. It is believed that as human populations expanded and developed better hunting technologies, such as projectile weapons, they may have begun to pose a real threat to even the largest of animals. This theory is supported by findings from other regions, where large animals disappeared in conjunction with the arrival of humans wielding advanced tools and weapons. Additionally, human predation may not have been limited to direct hunting. Over time, early human activities could have indirectly impacted Paleoloxodon namadicus by competing for food resources or altering their habitats. The interaction between Paleoloxodon namadicus and early humans remains a fascinating area of research, with significant implications for understanding the causes of extinction for large prehistoric mammals. However, human hunting was likely not the sole factor in the decline of Paleoloxodon namadicus. Like many other large animals of its time, it faced environmental pressures stemming from changing climates. Towards the end of the Pleistocene epoch, the Earth experienced a series of cold climate trends. These cold periods, often referred to as glaciations, drastically altered the habitats that Paleoloxodon namadicus depended upon. As grasslands turned to arid steppes and forests began to shrink, the food supply for these massive elephants would have dwindled. The inability to find sufficient quantities of nutritious vegetation may have weakened populations, making them more susceptible to disease and predation. As Paleoloxodon namadicus faced growing challenges from changing climates and increased human hunting pressure, its populations began to decline. This pattern was not unique to Paleoloxodon namadicus. Other large mammals in Asia, such as the massive rhinoceroses and other Paleoloxodon species, experienced similar fates. These extinctions coincided with the spread of early humans and the onset of colder climatic conditions, suggesting a combination of factors that sealed the fate of these megafauna. The extinction of Paleoloxodon namadicus and its relatives is a poignant reminder of how interconnected species are with their environments. It also highlights the profound impact that early human activities had on the world around them, even in prehistoric times. Despite its enormous size and strength, Paleoloxodon namadicus could not withstand the dual pressures of a shifting climate and the rise of a clever new predator. The tale of Paleoloxodon namadicus stands as a testament to the incredible diversity of life that once inhabited the Earth. As scientists continue to uncover more about this prehistoric elephant, they are not only piecing together the puzzle of a giant, but also deepening our understanding of the dynamics between climate, environment, and human activity. The research on Paleoloxodon namadicus continues to evolve, with new discoveries constantly reshaping our perception of what these majestic giants were like and what ultimately led to their disappearance. The range of Paleoloxodon namadicus was impressively vast. Fossil evidence points to a wide distribution across Asia, indicating that these prehistoric elephants thrived in a variety of environments. Remains have been unearthed from regions spanning from India to Southeast Asia, suggesting that Paleoloxodon namadicus roamed across what are now diverse countries and landscapes. Their adaptability to different habitats played a crucial role in their ability to spread over such large territories. However, despite this extensive range, changes in the environment over time presented significant challenges to these giant elephants. The climate during the time of Paleoloxodon namadicus experienced fluctuations that had profound effects on the ecosystems they inhabited. Towards the end of the Pleistocene epoch, the Earth went through a series of glacial and interglacial periods where temperatures and sea levels shifted dramatically. These cold spells resulted in changes in vegetation patterns, often replacing lush, green grasslands with colder, less hospitable environments. For an animal as large as Paleoloxodon namadicus, which relied heavily on abundant vegetation to sustain its immense body, such habitat changes would have posed a severe threat to its survival. Additionally, these climatic shifts may have affected water sources. Large elephants require significant amounts of water, not only for drinking, but also for cooling their bodies. A loss of wetlands and watering holes could have further compounded the challenges posed by a shrinking food supply. Moreover, the spread of cooler climates would have altered the distribution of flora, potentially forcing Paleoloxodon namadicus to migrate or face starvation. These environmental pressures were likely compounded by another looming threat: early human populations. While climate change was a significant factor, human activities could have played a crucial role in the decline of Paleoloxodon namadicus. The spread of early human populations into the territories of these massive elephants coincided with advances in hunting technology. Early humans were becoming increasingly proficient with projectile weapons, such as spears and arrows, which could inflict significant damage on even large animals. Evidence from other Paleoloxodon species suggests that humans may have actively hunted these elephants, not only for meat, but also for valuable resources like tusks and bones. Furthermore, as human populations grew and settled in different regions, they may have altered the landscape through activities such as fire use, clearing land for shelter, and hunting other herbivores. These activities could have led to a reduction in the available habitat for Paleoloxodon pneumaticus, effectively squeezing them into smaller and more fragmented areas. When combined with the climate-induced reduction in food sources, the impact of human encroachment likely became a tipping point that contributed to their extinction. The decline of Paleoloxodon pneumaticus was not an isolated event. It was part of a broader pattern of megafaunal extinctions that occurred around the same time across Asia and other continents. Large animals, such as the woolly rhinoceros, the giant sloth, and other members of the Paleoloxodon genus, also faced extinction during this period. This widespread loss of large animals indicates that the pressures affecting Paleoloxodon pneumaticus were not unique, but part of a global shift in the balance of life on Earth. Despite their extinction, the legacy of Paleoloxodon pneumaticus and its relatives lives on in the modern elephants of today. The closest surviving relatives of the Paleoloxodon genus are the African bush and forest elephants. Studies of mitochondrial DNA have shown a surprising connection between these modern elephants and their ancient relatives. For a long time, scientists assumed that the Loxodonta genus, which includes African bush and forest elephants, and the Paleoloxodon genus, were only distantly related. However, recent genetic studies have revealed a closer relationship between the forest elephants of Africa and the extinct Paleoloxodon. This genetic connection suggests that Paleoloxodon and modern African forest elephants shared a common ancestor more recently than previously believed. The discovery of this link has provided valuable insights into the evolution of elephants and highlights the complex relationships between the different members of the elephant family tree. Although Paleoloxodon pneumaticus is long gone, its legacy lives on in the DNA of its modern relatives, which continue to roam the forests and savannas of Africa. The survival of modern elephants serves as a living reminder of their ancient counterparts and underscores the resilience of these remarkable creatures. Despite facing numerous challenges throughout their evolutionary history, elephants have adapted and survived through countless changes in climate and habitat. However, the story of Paleoloxodon pneumaticus also serves as a cautionary tale about the vulnerabilities of even the most massive creatures to environmental changes and human activities. Looking forward, paleontologists continue to speculate about the possibility of discovering even larger prehistoric elephants or other massive land mammals. The fossil record is far from complete, and every new discovery has the potential to reshape our understanding of Earth's past. There is a tantalizing possibility that somewhere, buried beneath layers of sediment, lies the remains of an elephant or another giant mammal, even larger than Paleoloxodon pneumaticus. Such a discovery would not only challenge our perceptions of prehistoric life, but also provide new insights into the evolutionary strategies that allowed these giants to thrive. Researchers are hopeful that ongoing excavations and advancements in fossil analysis techniques will yield more information about the true size and lifestyle of Paleoloxodon pneumaticus. By finding more complete skeletons, scientists can refine their estimates and gain a clearer picture of the physical characteristics, behavior, and ecological role of these prehistoric giants. Understanding the full story of Paleoloxodon pneumaticus is not just about measuring bones. It's about piecing together the puzzle of an entire ecosystem and understanding how it functioned in a world long before humans left their mark. In the broader context, the quest to learn more about Paleoloxodon pneumaticus reflects a deeper human curiosity about the natural world and our place in it. These ancient giants evoke a sense of wonder and awe, reminding us of a time when the Earth was inhabited by creatures of almost mythical proportions. The study of Paleoloxodon pneumaticus is not just a scientific endeavor. It's a journey into the distant past, where we can glimpse the grandeur and fragility of life in an era far removed from our own. In closing, the story of Paleoloxodon pneumaticus offers a fascinating glimpse into a world where mammalian giants roamed freely. From their rise to their ultimate extinction, these prehistoric elephants exemplify the dynamic and ever-changing nature of life on Earth. While they are no longer with us, their fossilized remains continue to inspire awe and curiosity, prompting us to explore and understand the forces that shaped their existence. The research into Paleoloxodon pneumaticus also carries important lessons for the present and future. As modern elephants face their own threats from habitat loss and poaching, the story of Paleoloxodon pneumaticus serves as a reminder of the fragility of even the mightiest creatures. Just as these ancient giants were unable to withstand the pressures of climate change and human encroachment, today's elephants face a similar challenge. By studying the past, we can better appreciate the urgency of protecting and preserving the magnificent creatures that still share our world. In the end, the legacy of Paleoloxodon pneumaticus is not just one of size or strength, but of resilience and adaptation. These elephants were the culmination of millions of years of evolution, shaped by their environment and the challenges they faced. Although they have vanished from the Earth, their story continues to captivate and inspire, reminding us of the incredible diversity and wonder that exists within the natural world. As we continue to search for more fossils and uncover new secrets, the true scale and majesty of Paleoloxodon pneumaticus may yet be revealed, adding another chapter to the unfolding story of life on Earth.